Okay, so example 4 asks us to find inverses. First of all, I will say inverses are something we did in Algebra 2. Wouldn't surprise me if even technically they are part of Algebra 1. I don't know. But in order to find an inverse, we talked about it yesterday. It was at the bottom of the front page. To find an inverse, you're going to switch x and y and then solve for y. So, with that in mind, now, first things first. What do you know about f of x?
Y.
F of x is the same thing as saying y, isn't it? So really this equation is y equals x over x plus 1. So to find the inverse, every place you see an x, we're going to replace it with y. Every place we see a y, we're going to replace it with x. So instead of y equals, x equals. Instead of x over, y over. Instead of x plus 1, y plus 1. Okay. Now, the question here, and this one's not exactly the easiest one, but how do we solve for y? We can't cancel them. And here's what I'm going to say is we can't cancel these y's because of this plus 1 here. That y plus 1 can't be separated.
Do the y times y minus 1.
No.
Yeah, then I
Do you look at the graph?
No. Okay. How do we get rid of a fraction? Because right now I have a fraction.
Multiply by y plus 1.
Multiply by that denominator, get that denominator out of there, right? So my first suggestion here is going to be that we multiply by y plus 1. I know, I was going to take his multiply earlier, but then he talked about multiplying by what would be the conjugate. So multiply by the denominator to get the denominator out. Now, if I multiply the right by y plus 1, that means you're multiplying the left by y plus 1. On the left, when I multiply y plus 1 times x, let's go ahead and multiply. How do we multiply x times y plus 1? Okay. Yeah, go ahead and distribute. X times y is xy plus x times 1 is x equals. On the right side, we just have a y because your y plus 1s will cancel. Okay. Remember, my goal is to solve for y. I didn't get it written in here, but what did we do? Our first step was to switch x and y, right? And now we are working on solving for y. Those are the 2 steps I'm taking. So I have 2 y terms. We want to have those y terms be on the same side. How would you like to accomplish that? Since we already have a y here on the right, and I have this xy term that I'd like it to join on the right, I would take the positive xy and I would subtract xy. If we subtract xy on one side, subtract xy on the other side. On the left now, xy minus xy cancels, and I'm left with x. On the right, y minus xy is y minus xy for the moment. What do you notice about both terms on my right? They both have a y, yes? So that y we could call our GCF.
Sure.
Okay. And if we have a GCF, here's the deal, guys. We have to get y by itself. And right now we have 2 y's, but we have an x stuck to one of the y's, but not the other y's. It makes it a little complicated. So, what?
You divide the x.
Well, that's the thing. I can't just divide the x.
Negative x.
It's going to make a mess. So think GCF. Okay? GCF of y and xy is y. So I'm going to factor out a y. Now, what's left in the parentheses?
Negative x.
Not just negative x.
Negative x. 1 minus.
Yeah. On the first y, what's y divided by y?
Oh, 1 minus x.
Y divided by y is 1. Minus xy divided by y is x. Now, we're almost there. We have one last step. Our goal is to solve for y. We want y by itself. We right now have y times 1 minus x. So if it's y times 1 minus x,
Divide 1 minus x.
now I'm ready to divide by that 1 minus x.
We just did all of that over 1 minus x. Did I say 1 minus x?
Okay, now with that, we end up where our 1 minus x is canceled and we have y equals x over 1 minus x.
Is that how it's gonna go every time?
Like, are we going to have those exact steps every time?
Well, like, it'll be the opposite.
No, not necessarily. As in, can we just, oh, hey, switch that plus sign to a minus sign? No. Okay. Okay, now, with this, the one thing I will mention, if we put it in, it originally started off as f of x. Since this is the inverse function, you could write this answer as f inverse of x equals x over 1 minus x. I don't think I left quite enough room in that section. Oh, just for that one problem right there.
So technically, couldn't you just put the graph into the calculator and do the horizontal line test
To find out,
if it has an inverse?
yes.
But you could,
But that's not, this question was find the inverse. This question is what's the equation of the inverse? Okay. Okay. Let's try B. What do we know about f of x?
Y.
F of x is the same as saying y. Okay, so we have y equals square root of 4x minus 3. How do I start to find my inverse? No, not yet.
switch on.
Switch x and y. Maybe you've already done that, but I haven't done that.
Wait, you can do that without. Like you can switch it under the square root.
When our step is to find the inverse, we have to take an x and a y and just switch their location. So any place you see an x's, they become
You
y's.
can just do
When you're trying to find the inverse, yes. Not like in solving an equation or anything. Okay.
I was thinking it had to.
So instead of y equals, I'm going to have x equals. Instead of square root of 4x minus 3, square root of 4y minus 3. Now I'm ready to talk about how do I solve for y.
square.
Now I will square it.
Sweet.
Now I'm willing to do that. So in order to get rid of a square root, you square that side. If you square that side, you square the other side. When we take x and we square it, we're going to get x squared. What about when you take a square root and square it? Yeah, when you square the square root, they cancel each other and you just get 4y minus 3. Now what?
Add 3. Either.
Yeah, we're trying to solve for y. This one's an easier one. I hope you're seeing that. If it's 4 times y minus 3, then we want to add 3 on both sides. I'm going to flip my equation here. So I have 4y equals x squared plus 3, if you will.
Yep.
And to get y by itself, divide by 4. What am I dividing by 4? Everything. Now, on the right, you could write x squared divided by 4 and 3 divided by 4 like I did, or you could just write x squared plus 4, 1 fraction bar, x squared plus 3, 1 fraction bar, and 4 in the denominator. Okay? Now, as we clean this up, 4's cancel and we have y equals, right? So, y equals x squared over 4, x squared over 4 plus 3 over 4. I can't clean those up anymore. Again, if you put it as x squared plus 4, dang it, x squared plus 3 all over 4 is 1 fraction. That is fine as well. Okay? Official notation, function notation says f inverse equals x squared plus 4 over 4 plus 3 over 4. Okay? And C, we'll practice because it's yet a different one. Oh, and by the way, notice my original problem was a square root. My final answer was not a square root, was it? So it wasn't just like switching a sign, like I know some of you are like wanting to look for a shortcut. Okay. Okay, on C, f of x equals 4x squared minus 7. We, of course, know f of x to be same as y. Okay, so what's my first step here?
Switch it.
Switch them. Instead of y equals, I'm going to say,
X
instead of 4x squared minus 7,
4y squared minus 7.
okay. How would you like to solve?
Add 7.
Okay, if it's 4y squared minus 7, we're going to add 7. I think I'm going to go ahead and switch my sides. I'm going to say 4y squared equals x plus 7.
Where would that
Would you divide by 4?
I would have said, yeah, I would have said divide by 4 and then square root. You could go ahead and square root it. It just gets a little more tedious. So 4y squared divided by 4 becomes y squared. X plus 7 divided by 4 is what I wrote this time, and I'm just going to write it as x plus 7 divided by 4 for the moment. Now I'm ready to square root it. If I square root one side, we're going to square root the other side. Now, okay, what are the catches?
You also just square root just the 4. Just the 4. So the
Okay.
square root's on top, but it's x, so it's like square root of x plus 7 over 2.
Okay, so square root of y squared is just y. On the right, we have square root of x plus 7. I can't really do anything with that. But square root of 4, we can in the denominator, can't we? And that's a smart move. So square root of x plus 7 all over 2. What's the other little trick?
plus minus.
We took a square root in an equation situation, so we do need to say plus or minus. So y equals plus or minus the square root of x plus 7 all over 2. Or if I write it with my function notation, f inverse of x is equal to plus or minus the square root of x plus 7 all over 2. Goodness, I struggled to write that one. Okay. every inverse is different, right? I tried to give you 3 very different examples to give you an idea. Obviously, that first one was the harder one in this situation. Look for some of these steps and techniques, okay? Okay, yes?
I'm pretty sure I still have some Alana set.
Yes, shut them off. Okay, one last topic. Well, I don't know, has several pieces to the last topic, but the idea about inverses, okay? We just practiced how to find an inverse, and that is the switching the x and the y and solving for y. Now, when we talk about a graph, and we're going to do that here on example 5, a function and its inverse are symmetric across the line y equals x. Okay, so graphically, to decide if you have an equation and you have 2 equations graphed, to know if they are inverses by looking at the graph, they are symmetric across the line y equals x. And we'll talk about that here in a moment in example 5. Now, the other thing we're going to talk about down here is the inverse composition rule. And the inverse composition rule, so compositions being like Pog and Goff, that type of thing, a function f is one-to-one with an inverse function g if and only if f composed with g of x equals x and g composed with f of x equals x. So if you have a function and its inverse, and you compose them, so like you put them together, like do f of g of x or g of f of x, in both cases, they will always equal x. And that's another little test we can do to decide if 2 functions are inverses. Okay? And we'll talk about that in example 6. So, example 5, first of all. We're asked to sketch the graph of the inverse function for the function drawn here. Okay? So we have this, looks like probably what a cubic function is. Looks like, to me it looks like y equals x cubed, but just moved up 1. Okay? We want the inverse. Now, the inverse function is symmetric across the line y equals x. Okay, that's one thing to think about. Now, what's the line y equals x look like? Y equals x is that diagonal line that has a slope of 1 and a y-intercept of 0. So it's the line here that goes through 1, 1, 2, 2. I don't know if I can get this at this angle. But it is that perfect diagonal line. And I was just going to kind of draw it in here a little bit. Easier said than done, of course. Now, the key is taking this graph and folding it across that diagonal line is easier said than done, isn't it? Okay, it's a little bit easier when you have just a straight, either vertical or horizontal line to fold something in half and know what's going to happen. But this diagonal line, it's a little bit difficult. Now, when we were finding our inverse functions, like back here on this previous section, right? What were we doing right here? What was our step 1 in finding our inverse function? We were switching our x's and y's, right? That can be done in ordered pairs as well. So as we look at this problem, and let me look for a different color here. Okay. So, for instance, right here on the given graph, this point where my graph crosses the y-axis is the ordered pair, what? 0, 1. Okay, so think with me. 0, 1 on the original graph is going to become what?
1, 0.
1, 0. So now that means I'm going to have a point on 1, 0. Okay, this will help us get some points to locate. It also looks like there's a point at, what is that? Negative 1, 0? What's negative 1, 0 going to become? 0, -1, so that means I'm going to have a point down here, yes? Okay. Somewhere right in here, there's a point that crosses y equals x, yes? Well, guess what? That point that crosses y equals x is going to be the same. Because if it's on the line y equals x, that means its x and its y value are the same, right? And so when you flip those two, it's still going to be the same, right? And I don't know, I mean, it's not exactly, it's not like it's at -1, -1, but say it was. If it's at the ordered pair -1, -1, well, when you flip those, you're still at the ordered pair -1, -1. Okay. I don't know, is there a point maybe around 1, 2? Ballparking it, right? Looks like maybe there's a point around 1, 2. Well, if there's a point around 1, 2, what's 1, 2 going to become? 2, 1? Now, I don't know. That's about the best I can do for some points. You can pick some more points if you want, but here's my thing. I need, as I try to make this happen, okay, look at what's going on the other side of the line. Okay, so like, no, these points, we're not going to do a straight line, am I? I'm trying to mimic what's going on over here. So for instance, like between these 2 points on the axis, my graph is curving out and away from y equals x. So I see it as curving out and away from y equals x. Does that make sense? So maybe something like that. Okay. Up here, what's my line doing? It's curving in a little bit and then curving over to go through 1, 2. So if I curve in towards my line and then go through 1, 2, it's going out to the right. Down here, I need to hit that next point, don't I? And if I hit that next point, and then where am I going to go after that? I'm just going to continue. I'm just going to continue out. Okay. Not exact, but does it give you an idea? Okay. I'm not saying you could use this to draw it, but if we were able to take my VinQ screen and fold it on that gray dotted line, does it look like it might match up? Okay, approximately. So just, you know, it's kind of trying to, okay, I'm trying to mimic. This goes out and about. I'm going to kind of go out and about. This curves in. I'm going to curve in. So on and so forth. Okay. I think if I recall, you have a couple graphs to sketch. I don't remember for sure, but. Okay. Example 6. This one, so example 5 was sketch the graph of the inverse function. Okay, so we were looking graphically. Example 6 is being asked to show algebraically that f of x and g of x are inverse functions. Okay, so yeah, I could graph both of these, and if I graph them, what should they look like? They should look like they reflect on the line y equals x. Okay? Your charger's on the floor. Okay, now, algebraically, how do we show this? If these are truly inverses, fog, f composed with g of x, so f of g of x will equal x, and goth, g composed with f of x will equal x. So let's try these, okay? Let's start with fog.
What do you mean by equals x? It just literally equals
It will literally equal x. Okay? So, f composed with g means we're doing f of g of x. Now, Okay, recall f of g of x. That means I'm going to take whatever g is and plug it into f. Okay, are we getting better at this? So f tells me to do something cubed plus 1. That's my outside shell. G is what I'm going to plug in. So G, since I'm plugging that in, every place I see an x, I'm going to replace it with cube root of x minus 1. So if we think of this, f of x is something cubed plus 1. What's the something I'm putting in? My g. So the cube root of x minus 1 cubed plus 1. Does something around there work for you? Now, take a guess. What happens when you cube a cube root? Cube and the cube root can effectively cancel each other out, and we're left with whatever's under the radical, which is x minus 1. And then we still have hanging around outside a plus 1. What is x minus 1 plus 1? It is x. So what did we just show there? We just showed that f composed with g of x is equal to x. So, does that prove that they are inverse functions? Almost, but not quite, right? Because if they are truly inverse functions, it has to work the other way too. So we also have to check g composed with f of x. So g of f of x. Okay. So now that means I'm taking f and I'm going to put it into g. What is my g? My g is the cube root of something minus 1, right? But I'm going to plug f in. What is f that I'm plugging in? X cubed plus 1. So in place, I replaced x with x cubed plus 1. Okay, do some cleanup. What do you know under the radical? X cubed plus 1 minus 1 is going to be x cubed. So now I have the cube root of x cubed. What's the cube root of x cubed? X. So what did I just show here?
X equals g of x.
G composed with f of x is equal to x. Now, officially there's nothing to answer here because the directions were to show. And that's exactly what I did. I showed. Okay? Now, I did not think to get my assignment written up here. Page 122, 1 through 6, 9 through 12, 14 through 22 evens. I don't remember exactly what it means on that, but I wrote no domains. So they must be asking something about domains, and I'm saying forget that. And then 23 to 29. Okay. Be working.